Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to watch it later on. Following today's event, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. Okay, with that, I'd like to go ahead and kick off today's webinar, which is Kubernetes 101, an introduction to containers, Kubernetes, and OpenShift. Our speaker today is John Walter, who is Solutions Architect in the Training and Certification at Red Hat. Hey, John, how you doing today? Thanks for joining me.
Hey, Charlene. Good. Thanks for having me.
Awesome. Well, I'm going to put myself on mute and let you get right to your presentation.
Awesome. Well, thanks again. I'm John Walter. I'm the Solutions Architect for the Training Certification team here at Red Hat. And today we're going to be talking about Kubernetes, essentially an introduction to container technology, container orchestration, and ultimately OpenShift, which is our container platform. Just a brief overview of what we'll cover. We'll start at the container level, right, at the smallest piece, and kind of grow out from there, right? So what is container? What is Kubernetes? Why do we need something like container orchestration? And ultimately, what is OpenShift? And then we'll end with talking about some of the ways that you can leverage Red Hat's training certification offerings to get started with containers or to take your existing skill set to the next level. And as Charlene mentioned, we'll have time for a question and answer at the end. So I encourage you, if you have questions throughout the presentation, to drop them in that questions section within the platform, and we'll be able to take those at the end. So we'll start out with what is container, and really before we even jump into that, let's talk about the way that things have been done for really the last 20, 30 years, right? A big buzzword within the industry right now is digital transformation, and really the idea of digital transformation is how do we become a more efficient software delivery company, right? How do we change our development processes from something that is deeply siloed or waterfall towards something that really leverages continuous integration and continuous delivery? How do we go from deploying to on-premise data centers to deploying our workloads into the cloud? The goals of each of these steps should really be to focus on the business outcomes, and those should be centered around speed, agility, and control. And so when we talk about these 3 things, speed is really to mean how quickly we can deploy new ideas and how can we do it more efficiently than we already are. Agility meaning how can we update the process that we have? How can we do this more simply so that we can experiment more, so we can innovate more, so we can work on initiatives that are much more meaningful? And then finally, with control, it really is talking about risk, right? How can we make sure that security and bug resolution becomes something that can be approached faster and more agile? And speaking of agile integration, we need to essentially define a new way to develop our applications the way that we're designing them. We need them to be more agile. They need to be more scalable. They need to exist across public and private and hybrid clouds, and ultimately they need to be able to be iterated more quickly and more efficiently. And so that brings us to containers. And answering the question what is containers is different depending on who's asking. When you talk to someone on the infrastructure side about what containers are, they think of them as essentially lightweight, more simple versions of a virtual machine. And we'll talk about that a little bit in depth in the following slides. When you talk to an application developer, their idea of a container is totally different, at least their approach as to why containers may be beneficial to them is completely different, because for them, they think of all of the work that goes into developing an application and all of the underlying dependencies that the application needs. For them, a container gives them the opportunity to not really have to worry about any of that underlying architecture, because they're able to build in all of these dependencies into their application. And we'll talk very in depth in the subsequent slides around this. But really, again, we want to talk about where we've been and where we're going, and why containers is that direction. So, for years and years and years, typically organizations were deploying their applications in data centers. They would have dedicated servers for dedicated applications. And then as hardware got more efficient, we started to move towards virtual machines. And the benefit of virtual machines is that you can essentially co-locate multiple applications on single virtual machines and have multiple virtual machines running on a single server, right? And so really this was cutting down operational overhead, resource costs of maintaining virtual machines versus maintaining full-blown servers. And that was great, right? That was a huge step forward from the way things were doing, but it offered, or I should say, it didn't really address certain issues, right? Virtual machines are isolated from each other, but the applications themselves are not. And so if you look here on the left side, you see what a typical virtual machine looks like, right? We have our underlying hardware. On top of that sits a hypervisor. So if you're using Red Hat technology, that might be Red Hat virtualization. And then on top of that sits the virtual machine. And inside of that virtual machine, you have your kernel, you have your OS dependencies, and then you have each of these applications sitting on top. And so while you can have multiple virtual machines sitting on top of a hypervisor, and those are isolated from each other, the applications that are running inside of those virtual machines are not. And so that provides or can create issues as far as security, or having multiple versions of an application that need multiple conflicting dependencies, right? So this is where the benefit of containers comes along. Typically, your container is sharing a container host. So let's say it's a RHEL host, right? So it's accessing that same underlying kernel. And at the same time, it's using the same kind of kernel technologies you would be used to with just your RHEL system, right? So control groups and SE Linux and namespaces, and all of these things are providing isolation so that one container can't access or impact the other containers that are on that same host unless you design them that way. And so we'll get into this a little bit later, but there you see a distinction between the virtual machine and the containers, specifically around operating system dependencies. And we'll talk about why that's so important in just a little bit. But really, containers are in a way just a virtualization technology. VMs are for virtualizing hardware, while containers are for virtualizing the application processes, right? All of the things that an application needs to run, we're able to package within the application inside of a container, as opposed to having to rely on what the operating system is providing us. And so, while it's possible to run every application on a single virtual machine, the overhead, the resource costs, it's just really invalidates any of the perceived benefits. Virtual machines have the advantage of providing hypervisor level isolation for your apps, but it comes at the cost of you have to run a full-blown operating system, right? When you're running a RHEL VM, there's not really a lightweight version of RHEL that you're going to want to run to fully support that application. And virtual machines, they have compute and memory capacity that's all predefined. It's all based on what that underlying hardware is providing to you. Whereas containers provide isolation through taking advantage of all of that underlying operating system technology. So things I mentioned before, the kernel, namespaces, SE Linux, all of these things have been in production for years and years from a OS perspective, and the container is able to take advantage of that. And so since containers are using all of these shared underlying OS features, the amount of resources they need is virtually nil compared to what a virtual machine needs. And so containers are providing an agility that's just not really feasible with virtual machines. It only takes a few seconds to spin up a new container, but it takes minutes, sometimes hours to deploy a fleet of virtual machines, whereas you can spin up thousands of containers in just a matter of minutes. And so this all kind of ties back to DevOps, right? DevOps adoption has really skyrocketed in the last few years, and all this really coincides with the proliferation of containers within our industry. And this is a fact that's not really a coincidence, right? Containers have played a really important role in enabling organizations to be able to implement DevOps without certain obstacles that they once had to face with data center centric or virtual machine centric deployments. And so if you look at virtual machines as being a unit of compute, the applications are developed by the dev team. So here on the left side, we're really looking at the way that applications are built. And so you have your developers who are building out these applications. They're delivering these arbitrary packages, which typically vary between teams and applications, and they're delivering these applications to the IT or operations teams. And then they're responsible for building and deploying and managing whatever that application is sitting on. So in this case, a virtual machine. And so they have to manage, not just the application that's just been handed to them by the dev team, but then they have to figure out all of the dependencies that application needs to actually run. They have to manage the operating system. They have to manage the underlying architecture. So they're now responsible for managing that application in a way that they probably shouldn't be, because it's just not really their forte. This creates kind of a conflicting atmosphere between your dev and your IT ops teams and other teams that are involved in that application delivery, because now your ops teams are forced into ownership of this application and the dependencies that they're not really familiar with, and they have to rely on hopefully the instructions that they were given by the dev teams. On the right side, we see how this divide or conflict is resolved with containers, because there's a clear boundary between the layers within the technology stack that the ops teams and the dev teams are responsible for, what they own, what they manage. And so here, the dev team is still responsible for the application. They're deeply familiar with the app that they're building, and they know what dependencies and configurations it needs, right? But previously, they would hand off that application and give some instruction about what all of those dependencies that application needed to run, and then the ops teams were responsible for putting that in place. Where here, they're able to actually package the application with all of those dependencies it needs, and that's what creates a container. So think of a container as your application plus all the things that application needs to run, all in one file. And that's why we talk of it almost like it's its own VM. But the benefit here is that when you have multiple versions of an application that have multiple dependencies, well, typically in the past, you would have to spin up a new virtual machine for each of these apps, because you can't have conflicting dependencies on one place. Here, though, we can have as many differing versions of these applications as we want, because the dependencies themselves are isolated within the container. And so we don't have to worry about what is underneath the container, because everything is packaged inside there. And so now, instead of handing off essentially an incomplete product with this application from the dev team to ops, now you're handing something that your ops teams are able to go ahead and they can just worry about the infrastructure, which is what their responsibility is. They're able to manage the container host or the virtualization host that it's all sitting on top of, and they're able to deploy and monitor and manage these containers because they don't really have to care about what's on the inside. And so ultimately, using containers, these teams can work at different speeds. They can upgrade and downgrade applications or the underlying hardware independently of each other. They don't really have to worry about what these other teams are doing. And so while it sounds as though these teams no longer really have to worry about each other, it really actually allows them to build clear boundaries so that they can work in tandem more efficiently. And so Another really big kind of distinction between virtual machines and why people are moving to containers is that, there's never really been a standardized virtual machine format. In other words, if you're using vSphere, VMware for your VMs for on-prem, and they're tied to vSphere, it's not the same. It's not going to run the same way, or any applications running on that are not going to run the same way as they would if you had them deployed onto AWS or something like that. Moving applications between all of these different infrastructures with virtual machines, it typically means starting from scratch, rebuilding the application as well as the infrastructure, because the application has to be built to run on specific infrastructure when working with virtual machines. And we're trying to go, as an industry, move more towards immutable infrastructure. We're trying to simplify deployments. We're trying to make it so we don't really have to manage software so much. And so that's where containers really, really come into play, because containers are able to essentially work across all of these infrastructures the exact same way. So take a look here. This is the same infrastructure here at the bottom, but instead of having virtual machines running on top of it and having those applications running in those virtual machines, we're now able to essentially divorce the application from any of the infrastructure, right? So now we just don't even care where it's deployed. It could be something on your own laptop, it could be something in your data center, it could be running in Red Hat virtualization, or running on VMware, running on the private or public cloud, all of the above. In fact, most of the time, it's going to be running in multiple locations. And as an end user, you want to make sure that you aren't ever really able to notice a difference. And so containers provide application portability. They have standardized image formats, and they're essentially just dependent on the OS, the underlying OS. So in this case, RHEL, Red Hat Enterprise Linux. And so what this does is enables teams to have better control on the IT ops side of the infrastructure where they're deploying the applications, because now they can innovate from an infrastructure standpoint and not really have to worry about how this is going to affect the applications that are running on top of it. But nevertheless, there are still issues that are introduced with this, right? Portability doesn't guarantee compatibility. And that's where something like a Linux distribution can come into play, right? Because the containers that are running are essentially lightweight Linux hosts, this allows any system administrator who would be provisioning everything below that dotted line, right? The OS on top of the infrastructure, they're now able to actually work with those containers as well, because the same skill sets they need to secure the platform are the same skills that it takes to secure the actual container itself. And so let's talk a little bit more about that, right? The really big key takeaway when we talk, and this kind of ties back to that original slide, when we talk about when you talk to infrastructure teams about containers, they're going to see and hear that in a totally different way than developers are. Developers are going to be talking about, oh, this container has my application, it has my operating system dependencies all packaged in one place. Whereas infrastructure teams are going to be thinking, oh, well, these containers are just really small Linux operating systems. I no longer really have to worry about any of the things underlying, but if I ever need to troubleshoot an application, I can just jump right into that container and do the exact same kind of troubleshooting that I would have been doing if it had just been running natively on an operating system. And so if you've been to any one of our events in the last few years, you may have seen, or any events that Red Hat has attended, you may have seen us walking around with Containers or Linux t-shirts. And this has been a really big kind of initiative internally, because we want to make sure that the bulk of containers that are out there are running Linux operating systems. Maybe not necessarily RHEL, but certainly Linux, because of its flexibility, its scalability, its portability. And so in a nutshell, containers are really transforming the way we think about application architecture. It's changing the way or how quickly teams are able to actually deliver on business requirements. And they promise portability across a hybrid cloud environment and allow developers to really focus on just building their apps. They don't have to worry about any of the underlying infrastructure, any of the execution details. They can just worry about building out their applications and continuing to build out those applications. They're able to continuously innovate and deploy updates to these applications. And so while containers remove the complexity through essentially minimalism, right? Where managing container deployments is now presenting a new opportunity, we'll say, a new challenge for these different operations teams. You know, while containers are deployed for a shorter period of time than virtual machines, there's typically greater utilization of underlying resources. And so related container technologies, they have to manage so many more objects, and there's a whole lot more turnover than the way that we have been doing in this older paradigm. And so this introduces the need for automated policy-driven management. And so a lot of teams are turning to Kubernetes, which we'll talk about next, to really help to orchestrate and manage containers in their test development and production environments. And so, Kubernetes has essentially emerged as the de facto standard for container orchestration and management, and it's become a really critical platform for organizations to understand. So let's dive into what is Kubernetes. So containers are really popular because they allow an application to run essentially as an isolated process, and it has its own resources. And containers aren't like VMs because they allow the Linux kernel to manage all of the compute resources rather than performing hardware virtualization like VMs typically do. And so because of this lightweight nature, it means that each application can have its own container, it can prevent dependency conflicts, and essentially it just means that each of these containers are like a zip file. And so keeping that in mind, containers are just a way to bundle code and configuration and dependencies in one place. And it eliminates the problem of, it worked in this environment, why doesn't it work in your environment? But as applications are increasingly built as more discrete functional parts, we're able to sort of break down each of these parts and deliver those as containers. And so that means for every application, there are more and more parts to manage. And it also means that they have shorter lifespans than a traditional deployment on a virtual machine. The complexity of managing all of these applications, all of these additional objects, there's greater churn. It introduces a lot of challenges, and those include things like configuration, service discovery, load balancing, resource scaling, how do you fix and find failures? Managing all of this is pretty impossible if you're going to do this manually, right? It's one thing if you want to set up an Etsy shop and you're going to need a lightweight database, you're going to need a web server, maybe an application to handle payment. That's three small applications, and if you're getting 10 hits on your website a month, it's probably pretty easy to manage that yourself. But obviously at the enterprise level, you're looking more at like thousands and thousands of these containers, and you need to have a way to be able to manage all of this. If you look at a traditional Kubernetes cluster, it's typically running thousands of containers, and updating these clusters would be impossible if you weren't able to automate those tasks. And so this is where Kubernetes comes into play. And so Kubernetes, it delivers production grade container orchestration because it's able to automate a lot of the configuration and scaling and resource allocation that you would otherwise have to do manually. The other big benefit is that Kubernetes can run anywhere. And so if you want your infrastructure to run on site, if you want it to be on a public cloud, if you want to move towards a hybrid cloud, Kubernetes is able to deliver that and scale across all of these varying infrastructures. And so in a nutshell, for your more complex applications, you're going to have multiple components. Containers allow you to really vastly simplify updates. So you can basically place a component of each component of that application can be its own container, and it really makes it easy to make changes, and you don't really have to worry about any of the ripple effects. And that simplicity has really led to containers becoming the way to develop and deploy microservices. And so think of microservices as just applications with a single function. And so they really benefit from being in containers because they provide really a clean separation between the components and then the actual services. So Kubernetes, it's an open source container orchestration platform. It manages it helps to manage your distributed containerized applications, and it allows you to do that at an enterprise scale. And so you tell Kubernetes where you want your software to run, and the platform just takes care of everything else for you. And it provides things like a unified API, so you can deploy web applications or batch jobs or databases. And then the applications that are inside of Kubernetes are packaged in containers, and they're cleanly decoupled from their environment. And so you're able to automate a lot of the configuration of your applications. You're able to maintain and track resource allocation, all of the things that you need to keep in mind. And so when we say this, it's container orchestration, what we mean is that it figures out where and how to run your containers. And more explicitly, it provides these three functions. So schedulers and scheduling. This means that Kubernetes is intelligently comparing the needs of a container with the health of your cluster, and it suggests where the container might fit. Think of a schedule sort of like your thermostat, right? You set your thermostat in my house to 70 degrees, which drives my friends crazy. And I expect it that at all times it's going to be 70 degrees in my house. And my thermostat's job, all that it's doing is periodically or probably constantly checking to see what the actual temperature is. And if at any point it drifts, it's going to turn on and readjust so that the airflow is actually back at 70. That's basically what Kubernetes is doing, right? It's constantly checking the health of applications, of the individual containers, the cluster itself, and it's able to adjust, so to speak, kind of change the temperature for you. And this allows, developers to not really have to worry if their applications are crashing continuously, something like that. Kubernetes is able to monitor that, and if a container is crashing, it's able to delete that container and spin one right back up for you. And so it allows your developers and your operations teams to be kind of freed of having to worry about that, and they can start to focus on new initiatives, building new applications, scaling out their environments, providing value for your business. The second feature, service discovery and load balancing. So, in any system, service discovery is a challenge, and Kubernetes is no exception there. The more services that make up your application, the more difficult it is for your application to track and to manage all of those different services. And so what Kubernetes does is it automatically manages the service discovery for you. And so you might ask Kubernetes to run a service like a database or an API, and then Kubernetes will take note about these services, and it can return a list if we ask them about it later. And so what it's doing behind the scenes is essentially checking the health of all of these individual services. And if it ever detects a crash, it's automatically going to attempt to restart it. And in addition to these basic checks, it also allows you to add more subtle health checks. So for example, maybe your database application hasn't crashed, but it's running really slowly. And so Kubernetes can track it and direct traffic to a backup if it detects any kind of slowness. And then it can also scale horizontally. So I always use the example of the holiday season here in the States, right? Typically shopping really increases around Black Friday, right after Thanksgiving. And traditionally, organizations, especially on the retail side, would have to start the process of scaling their virtual machines, scaling their infrastructure, and then ultimately scaling how many times their applications were replicated, starting around September, October, so that by the time they start to see spikes on their retail websites, they have the capacity for that. Well, Kubernetes is actually intelligent enough to know, hey, we're starting to get a spike in traffic, October 1st. How about I start to replicate this application so it's more highly available? And it's able to know that there's enough underlying resources to actually do this. And so that brings us to the resource management piece, right? Every computer, no matter where it's deployed, has a limited amount of CPU and memory, And applications that take advantage of, or different applications will take advantage of those different aspects, right? So something that maybe transcodes video is going to be more heavy and reliant on the CPU, whereas something that parses text is going to be a lot more dependent on the memory. And so this means that you never want to be able to be in a point where you're running out of these resources. And so Kubernetes has built-in resource management capabilities that are tied to the scheduling piece that we talked about before. And so Kubernetes is able to schedule applications to appropriately use resources when needed, and still kind of stays cautious about overutilization that leads to system stability. And so it's going to intelligently scale up your application or scale out your application, and just as importantly, will scale down when utilization is down. Some other benefits, scalability is huge, right? We talked about this a little bit early on, but having the ability to automatically scale your cluster based on your needs, and as importantly, scale down your cluster based on your needs, is going to save you, resources and money. If you're just reliant on your teams to essentially predict peaks in traffic, peaks in access, resource peaks, things like that, you may not have the most reliable environment. And so, if you have a couple spikes in traffic that were unexpected, and you weren't really prepared with a system that could intelligently scale itself, you may have crashes. Portability is also key. Kubernetes can run anywhere. It runs on site in your data center. It runs on the public-private cloud, or a hybrid of that. And so with Kubernetes, you're able to interact with that Kubernetes cluster no matter where it is, using the same set of commands. An admin who manages Kubernetes in one environment is going to be able to run it in a separate environment without any kind of issues. And part of that is based on its consistent deployments. The deployments are consistent across infrastructure. The containers embody the concept of that immutable infrastructure we talked about before. And so all dependencies, setup instructions, all that's bundled with the container itself. And then finally, separated and automated operations and development. So, it's common for operations and development teams to, we talked about this before, to kind of be in contention. And, typically it's because the ops teams are going to value stability. They're more conservative about change, whereas development teams really value innovation, and they prize, a high change velocity. And Kubernetes works to resolve this conflict because it offers, the intelligence and the automation, or the intelligence automation of the platform. Operations teams can feel confident in the stability of the system, and at the same time, because containers are saving developers time, they're able to and empowered to iterate change more quickly. So we won't spend too much time on this. I just wanted to give kind of an idea of what basic Kubernetes architecture looks like. Right here we essentially have a managed containerized cluster here, right? So we have servers that are made up of master and worker nodes. So if you're at all familiar with clustering on the OS side, it's very, very similar. But essentially, we have our master or control plane, and we have our worker nodes, and together they run applications or services. And so we have our control plane. Think of that as the master node. It's what controls scheduling and service discovery, load balancing, resource management. It provides access to an API server, and everything as far as memory is really stored here. And then we have our worker nodes, which are really what runs the application or the services. So, there are typically on a, this is the most basic Kubernetes cluster. Typically, you're going to have a lot of worker nodes on a cluster, and adding new nodes is how you scale Kubernetes. But what's missing here? Kubernetes offers, what did we say before? Portability, scalability, automated policy-driven management, but it's not a complete solution, or at least I should say it's not a complete enterprise solution. It doesn't include all the components that are needed to build and run and scale containers in production. It doesn't provide an operating system or a CI/CD tooling or application storage services or storage. And so a lot of work also has to be done for role-based access control, multi-tenancy, security. And so, Kubernetes offers a lot of pluggable interfaces for a lot of these things, but it's not built into Kubernetes. And, you see here, a few of these things we've talked about, but a lot of these things we haven't. Scaling is something that's built into Kubernetes, but what about configuration management? What about image management? What about security? So I talked about all of the pluggable interfaces that you can plug right into Kubernetes. That's what this looks like. All right. So the things that are highlighted in green with the white backgrounds, that's what Kubernetes provides. Everything else is something that you would need to essentially bake in yourself if you wanted to have that feature as part of Kubernetes. CI/CD being a big piece, API management, databases. How about the underlying OS? These are all things that organizations who adopt Kubernetes as their enterprise container orchestration platform are now having to essentially either buy or build themselves. So, ultimately Kubernetes on its own at the enterprise level, it's hard to do right. You can install Kubernetes, you can get a cluster up and running probably pretty quickly, but establishing it as a platform for your enterprise to run business critical application, it takes a lot more. If we talk about just one feature, identity management, right? With Kubernetes, you're going to be providing access to some pretty critical internal systems to the people who are using the platform internally, so your employees, potentially your partners, and ultimately to your customers. And so you have to adhere to the same security standards and rules that you've established throughout your company. And if you're just using Kubernetes, well, now you have to build some kind of integration between Kubernetes and your company's approved LDAP. And so that requires knowledge of DEX, which is an open source identity system. You need knowledge of Kubernetes. You need knowledge of the integration systems between Kubernetes and to LDAP. And then you'd have to hook up something like Prometheus, which does monitoring and alerting, just so you can get full visibility into all of the operations and testing and production. So that's essentially, you will have to hire in one person just to take care of this very one small component. All of these things need to be taken care of as part of an enterprise deployment. And so that's where something like OpenShift comes into play. So what is OpenShift? So OpenShift is essentially a platform built on top of Kubernetes that provides a lot of the things that we just talked about. No matter what architecture you choose, or what programming language the developers are using, or what services you want to use as building blocks, OpenShift is providing a single and consistent development model across the entire lifecycle, from build to testing to deployment to monitoring to review. And some of the things that it provides are things like self-service infrastructure, which allows developers to provision what they need on demand, and they don't have to skip on, or they don't have to wait on requesting somebody on the ops team to get the infrastructure ready for them and then deploy an application, which sometimes can take a few minutes if you know the guy, or maybe a few hours if it falls from the top of their inbox to the bottom. Or sometimes as many as a few days if you have to open up a ticket and it just sits waiting for you. Other things that it provides: consistent environments. OpenShift makes sure that the environment provision for developers and across that lifecycle of the application is consistent from the OS to the libraries to the runtime version. So for instance, the Java runtime to even the application runtime. So, for instance, something like Tomcat. And it's providing a consistent environment in order to remove the risks that are originating from inconsistent environments. It also provides an automated build and deployment. So built into OpenShift is a full CI/CD pipeline, so that developers can either choose to build their own containerized applications, or they can just contribute their full application that's ready to go and allow OpenShift to do all the work to containerize and test and deploy it for them. And then other features include configuration management, being able to configure sensitive data that's built into the platform, and it ensures consistent and environment agnostic application configuration is provided to the application, no matter what technologies are being used to actually build or deploy the application. And then finally, application logging and metrics. Rapid feedback is one of the most important aspects of application development. And so OpenShift has these integrated monitoring and log management tools that provide immediate metrics back to the developers in order for them to study how their application is behaving across changes and allow them to fix the issues as quickly and as early as possible in that application's lifecycle. And so I know this is a lot of information here, but essentially the takeaway is that OpenShift is a service built on top of Kubernetes. And so you see here that all of the container infrastructure services, other than orchestration and storage, are things that are not addressed by Kubernetes. And so things throughout, including lifecycle automation or container management, most of the infrastructure services are actually being provided, in this case, by OpenShift as a container platform. And it's all sitting on top of an infrastructure that we don't really have to worry about, because it's going to run the same no matter what or where it is. And we're able to integrate a lot of the middleware services and application development. So from an application services perspective for developers, their experience is not changing whatsoever. And I think this actually shows it a little better. Essentially what OpenShift is an integration of Kubernetes with cluster services, application services, service mesh, developer services, and automated operations, all bundled into a really clean and slick web interface, or for people who are more inclined to using the command line or terminal, being able to call all of these things from the terminal as well. But essentially, what we've built is just a Kubernetes platform, right? But it's a smarter Kubernetes platform because we've streamlined things like installation, the upgrade experience, really all functions throughout the entire lifecycle. And ultimately, this creates value for external and internal customers, and it depends on your ability to deliver applications more quickly. And so, we believe that containers, Kubernetes, DevOps are all key ingredients that a modern application platform should be based on, that allow you to really transform your traditional apps, build cloud-native applications, and ultimately experiment with things like analytics and machine learning, serverless applications. But this is an application platform, and it needs to provide a consistent way for developers and for operations teams to collaborate across all deployment footprints, no matter if it's an edge or air-gapped environment, to infrastructure you have in your own data center, and then ultimately to the hybrid and multi-cloud. A couple of features that we want to highlight as well. OpenShift is extremely easy to update, and OpenShift is going to be tied to a specific, every version of OpenShift is tied to a specific Kubernetes version, and it's also tied to the underlying OS. And so we make it really, really easy to simplify both the installation and then ongoing updates in a seamless over-the-air way. We want to make sure that upgrading the platform is as easy as updating your mobile phone. And then we talked about this a little bit with security. Static security policies and checklists just no longer really cut it, and they don't scale for containers in the enterprise either. And so to truly get the business advantages of containers, enterprises need to evolve their approach to security. And because security has become or needs to become a more continuous activity and has to be considered at every stage of your application infrastructure lifecycle, it takes a lot of planning up front and can lead to much more integrated security solutions and faster app delivery. Because securing containers is so much like securing running processes, you have to think about security throughout the layers of the entire stack. Now, the good news is everything that container platform is sitting on is Linux. And so for your system administrators, your operations teams, defending and securing the platform is exactly the same as what they go through securing the operating system. And it doesn't take much to secure the containers themselves. And some of the things that we rely on are secure registries, and think of registries as repositories for containers. Being able to isolate the network and storage so that only the applications are able to use them and not any of the users who are actually leveraging the applications. And then ultimately, no matter what infrastructure you choose, OpenShift is going to provide the necessary tooling and process automation that enables teams to operate Kubernetes efficiently and economically, no matter where it's deployed. In this case, you see, OpenShift can be sitting on a bare metal system, or even on, VMware vSphere or Rev or OpenStack. Currently, a lot of our training is actually being deployed on OpenShift, running on OpenStack, which is deployed on the IBM cloud. And a lot of the way that we're able to automate this is using something called operators. So I don't expect anyone to understand what these different categories are, but what they are resources. So everything within Kubernetes and within OpenShift is essentially a resource. So a deployment, a replica set, a stateful set, these are all objects. And what operators allow us to do is really automate a lot of the ongoing maintenance and operations throughout the life cycle. And so things like data rebalancing, doing seamless upgrades, all of this can be done with automated processes built straight into OpenShift, including the installation. In the past with OpenShift 3, you would have to have your infrastructure ready to go. You would install the operating system on top of that, and then you would install the OpenShift platform on top of the OS. With OpenShift 4, which we introduced about a year ago, you're actually able to do all of that in one go. And the nice thing is that now the OS is tied to the platform. So anytime that one of them requires an update, it's going to actually update both of them because they're synced in tandem. And what we've also introduced is something called Red Hat Enterprise Linux Core OS, which is essentially a lightweight container grade operating system. It's essentially only exists to be a platform for OpenShift to run on. And what this really allows you to do is, instead of having to manage 3 different things, on the left side, managing OpenShift as a platform, managing the operating system, and then managing the infrastructure, with OpenShift 4, you're able to do all of this as one piece. You now only have to manage one connected thing. And then this gives you kind of an idea of the operations, the operators I was talking about. So these are full automated operations that are built into OpenShift. So we provide automated installation down to full stack deployment, to scaling your cluster, security, network isolation, logging, patching, vulnerability scanning. All of these things are built straight into OpenShift to automate this entire process. But outside of these things, we work with a lot of vendors to actually build out operators as well. And so we launched something in conjunction with AWS and Microsoft and Google called the Operator Hub. And what this does is provides a single place within OpenShift that developers can access and then publish operators, and for customers to consume them. And you'll see there in the bottom right, some examples. A Dynatrace monitoring or Couchbase autonomous operator allows to easily deploy, manage, and maintain Couchbase. And so all of these vendors that you are working with already have integrations into OpenShift so that you can very quickly take advantage of Dynatrace, for instance, for your monitoring, and be completely supported within that as well. Full control for administrators. So admins are going to have complete control of the platform. We talked about role-based access control before, but being able to control not just who has access to specific operators, but also who has access to specific systems or specific clusters, to specific containers, to all of the above. Essentially everything within the workload is an object and can be managed, or role-based access control can be implemented on top of it. And then finally, we talked about this before, but self-service for developers. As a developer, being able to essentially check out an application, deploy it into a test environment, run your penetration or whatever testing it is that you need to do, and then promote it throughout the life cycle into the production environment. Providing that ability to developers directly so that they can very easily test their applications in the environment that they're going to be deployed into. So we've talked a lot about Kubernetes. Let's talk a little bit about training and what we have at Red Hat. So we offer a few different ways to train. Obviously, at the time we're recording this, it's right in the middle of the COVID-19 pandemic. And so for any of our in-person training modalities, those are currently unavailable, but we have a lot to offer from a instructor-led, virtual, and self-paced option as well. So right now we're really leveraging our virtual training. If you're looking for something that's live and instructor-led, it's held over BlueJeans, which is similar to like GoToWebinar, GoToMeeting. And then our online learning modality gives you self-paced access for 90 days to one of our individual courses. The emphasis of any of our courses, if you aren't familiar, is on hands-on labs. We provide a full-fledged lab environment for you, and you're able to essentially with every lecture topic go into a guided exercise inside of our lab environment and actually practice the things that you've just learned. So, we really encourage people to take advantage of that lab environment. And for those of you that are looking for something more than just a single course, I would definitely encourage you to take a look at our Red Hat Learning subscription. It's a 1-year access to our entire course portfolio, which is about 60 courses right now. And again, a full hosted lab environment for you. We provide 400 hours of access to that environment. So that equates to about 15 different courses over the course of the year. We do also offer a trial for this, a free trial for a week. If you go to the link there at the bottom, or if you just go to redhat.com/training, definitely take a look at the Red Hat Learning subscription trial. And as far as the actual curriculum that we offer from an OpenShift perspective, most of what we've talked about today is covered in our Introduction to Containers, Kubernetes, and Red Hat OpenShift course, which is the DO 180 there at the top. It's really geared towards everyone in the organization that may be interacting with OpenShift. So everyone on the IT admin ops side and everyone on the development side would probably want to start there and have that prerequisite knowledge before jumping into their respective tracks. For the administrators, how do you stand up the platform? How do I manage these resources? How do I deploy containers within the platform? The security DevSecOps folks, how do I secure the container images themselves? How do I secure the platform? And then again, for developers, how do I take our existing applications and containerize them? How do I leverage and build out a CI/CD pipeline? How do I implement and create microservices and build resilient microservices with things like Istio and Service Mesh? So highly encourage everyone who may be interested in some of these deeper level courses, definitely check out this introductory course. As a result of attending, you'll be able to containerize simple software applications, deploy them with Docker and Kubernetes and OpenShift, and then test those containers and troubleshoot them. And then for those that are developers who just don't really have the prerequisite Linux knowledge, don't really even care, right? You just want to be able to deploy your application in OpenShift. We actually have a developer-focused single-day course that I would highly encourage you to check out. Really just gives you a complete exposure to OpenShift without having to have any of the underlying knowledge of Kubernetes or of container technology. So we'll give you some sample applications that you can deploy, and you're able to test and scale and troubleshoot and fix those applications in a controlled environment. And so with that, I know we've gotten to the end of the presentation, so we'll start to take questions now.
All right, we have a couple minutes for questions, so I'm going to go ahead and just dive right on in here. First question for you, John, are they secured enough to work like VM, as host privilege user can make exclusive tasks like deleting container file systems? So how do we manage this?
So really good question. So containers natively do offer some security mechanisms, right? What we were talking about before, that you can essentially treat a container the same way that you would treat a Linux virtual machine, right? So the same kind of kernel isolation, namespaces, C groups, things like that are still come into play. But where Kubernetes kind of falls short is, there is some role-based access control built into Kubernetes as is, but how do we make sure that the container images themselves are secure, right? Where are we storing these images and who can access them? And so that's where things like OpenShift with registries really come into play to add another layer of security. And then, you talk about networking and storage and all of these other kind of components that have to be baked into your container kind of after the fact that Kubernetes doesn't really handle. Those are additional layers of complexity and additional things that you have to secure. And so out of box, something like Kubernetes definitely has some security mechanisms. It doesn't check every single box, right? It's not something that you would want to necessarily run in production and have thousands and thousands of users interacting with this application. That's where something like OpenShift comes in, because you have that additional layer of isolation, and you can really make sure that only specific users are able to deploy, able to access, able to edit that container or the image itself as well. So that's one of the kind of places where Kubernetes isn't exactly at the enterprise level yet.
All right, great. Let's see, I think we have time for one more. Can multiple microservices live on one container?
Yes, so you can definitely build multiple services and deploy multi-service applications. A couple of our courses actually teach you how to do this a few different ways. So, one of the ways, if you've used Docker ever, you can essentially create container images with something called a Docker file. I want to say it's not YAML, but it's another kind of markup language. It actually may be YAML, but it's so really easy to write, and you're able to essentially reference typically a single application, and the Docker file, when you run it, creates that container image from your application from source. But what this question is specifically referring to is, how do I package multiple microservices into a single container? And that would be one way to do it. Is just essentially creating a Docker file that referenced multiple services. Another way would, and probably the most common way, at least at the enterprise level, is leveraging your CI/CD pipeline to do all this for you. Typically your developer is not going to actually be converting source to a container image. They're going to finish coding, and whether it's a larger application or multiple microservices, and then they're submitting that into the pipeline, and the pipeline kind of does all that work for them.
All right, great. Well, we're about 3 minutes to the top of the hour, so unfortunately that's all the time we have for the question and answer period. We got a ton of good questions in, so I do apologize that we weren't able to get to more, but please know that the folks at Red Hat are getting a copy of all of the questions that were submitted, and I'm sure somebody from the organization will be getting back with you to get your question answered. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to www.devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, also at the top of the hour, I did mention that we would be doing a drawing for two $50 Amazon gift cards. So real quick, let's go ahead and do that. Our first winner today is David C. Congratulations, David. And our second winner is Sebastian H. Congratulations, Sebastian. We will follow up with both of you offline via email to get your Amazon gift card over to you, so please check your inbox. All right, with that, I'm going to go ahead and close out today's webinar. John, thank you so much for such great information. Judging from the number of questions we got, so many good ones. I know that the audience got a lot out of it. So thanks a bunch. Really appreciate it.
Thanks, appreciate your time.
All right, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.